All right, everyone, we're going to do a review of linear functions and parallel perpendicular lines and horizontal and vertical lines. So none of this should be new to you, but hopefully it'll be a really good review. So what I want you guys to do first is I want you to list everything that you can remember about linear functions. You can think about vocabulary terms or other kinds of concepts. List everything you can. Okay, so hopefully you guys have a really good list started. So I'm going to go over some of the main points that we want you guys to remember. So the first thing that I want you guys to have down is the concept that linear functions have to have a constant rate of change. That's why they don't bend or curve, because their rate of change is constant. And next, it's really important that you understand that the rate of change is the same thing as the slope of the line. And hopefully you remember the variable that's almost always used for slope is an m. Okay, next we're going to talk about the three different forms for linear equations. So you guys learned standard form, slope-intercept form, and point-slope form. So standard form is ax plus by equals c. Standard form isn't as practically useful as the other two forms, but it's kind of like the formal way to write the equation of a line. It is nice to graph lines using intercepts. I don't know if you remember this from Algebra 1, but if you plug in a 0 for your x value, you can find your y-intercept. If you plug in a 0 for your y, you can find your x-intercept. So sometimes standard form is really helpful when you're trying to graph lines. One last thing about standard form to remember is that the parts of the formula that get replaced with numbers are the a, the b, and the c values. And generally, those numbers are integers, except a must be a whole number. So in other words, a has to be positive. So first, let's go on to that second form for linear functions. This is probably the one that you're most familiar with. It's called slope-intercept form, and that one is y is equal to mx plus b. This equation will have the m and the b replaced with numbers, and then the x and the y stay there as variables. Remember what m and b stand for. The m is the slope. I've already mentioned that. And then hopefully you remember the b is the y-intercept. So it's aptly named slope-intercept form because the numbers in the equation tell you the slope and the y-intercept. The last one that a lot of students overlook and don't use as much as I think they should is point-slope form. So here's point-slope form. It's y minus y1 is equal to m times the quantity x minus x1. And then here, again, just like the others, the plain x and the plain y just stay variables. You're going to plug in numbers for y sub 1, m, which is your slope, and x sub 1. So point slope is really super helpful if you're given the slope and a point that the line passes through, because you can just plug numbers in basically, and it's a legitimate form of a line. If the question doesn't state otherwise, you can leave the answer in point slope form. So sometimes it's a big time saver. Okay, let's talk more specifically about slope and just review kind of the concept and the equations that we use to find slope. So the slope is practically the measure of how steep a line is and whether it goes uphill or downhill. So the numerical value of slope, I'll fill in that blank in just a second, but to find the numerical value of a slope, you want to find the change in y over the change in x. Hopefully you're familiar with that symbol. It's a Greek letter delta, so it stands for the change in the y and the change in the x. So another way to look at that is you could say it's the difference in the y's over the difference in the x's. And if you're looking at a graph in particular, a lot of people will use the term rise over the run. When you talk about rise, it's how far does the line go up or down versus how far does it go left or right. So then the last thing I want you to do is let's fill in that blank. This is also known as, slope is also known as a difference quotient. And if you specifically look at that part, it's a difference between the y's over the difference between the x's, and it's a quotient because you divide the two numbers. Okay, and the last kind of perspective that I want you to have is that remember that slope is a ratio, and you can look at it as the vertical change. Vertical is up and down versus horizontal, which is left and right. So lots of different ways to kind of say the same thing. All right, so we're going to apply these concepts to some examples. So for example 1, it's asking you to find the rate of change if you're given 2 points, and then write the equation in both point slope and slope-intercept form. I'm going to go ahead and add a dash right there. So first, find the slope. So remember, slope is, we find the difference in the y's over the difference in the x's. Now, where do we get those numbers? I always recommend that my students go ahead and label their points. And remember, it's always an x before before you put y. And these, since this is our first point, we're going to call this x1 and y1. And then the second ordered pair we will call x2 and y2. You can switch those. If you wanted to, you could say this is x2, y2, and this is x1, y1. That's okay. And as long as you don't, as long as you don't say this is like x1 and y2 right here. So make sure you're consistent in your numbering. So let's go ahead and plug numbers into the formula to find our slope. So our y2 is 7. The formula has the minus in it. And then our y1 is -1. Over, and then our x2 is 3. Minus is in the formula, and then our x1 is -1. So now we're just going back to concepts with adding and subtracting integers. Minus and negative is the same thing as plus, so we can rewrite this as 7 plus 1 over 3 plus 1, or 8 over 4, which is 2. So now we've got our slope. So because we're given 2 points, I would recommend going ahead and starting off in point slope form. So let's go ahead. I'm going to rewrite the equation. And I'm going to choose one of the 2 points. I like the idea of getting rid of negatives, so I'm going to choose this point right here, but it doesn't matter. You can choose either point and it's just fine. So we're going to plug those numbers in for x1 and y1, and then we can plug in the 2 in place of m. So y minus, instead of y1, we're going to put -1 equals m. Instead of m, we're going to put 2, and then times x minus, and then x1 is -1. So here we can go ahead and simplify that a little bit further into y plus 1 is equal to 2 times the quantity x plus 1. This is a legitimate answer. Notice it says, write the equation in point slope form. That seems like an unsimplified answer, and it is, but it's a legitimate point slope form equation. So we've taken care of the first thing that second sentence asked us to do. So now if we want to find slope-intercept form, we can just go ahead and convert. So now we can go ahead and simplify. So we'll have y plus 1 is equal to, we're going to multiply or distribute 2 times the quantity x plus 1, so we'll have 2x plus 2. And then we want to isolate our y value by subtracting 1 from both sides, and we get y is equal to 2x plus 1. And we're finished. Let's go on to one last example. So this one has kind of some messy numbers in it. I don't want you to be intimidated by messy numbers. It's okay. The concept and the procedure is exactly the same, so don't be messed up by the fact that sometimes you're going to have some fractions. So first, if we want to write the equation of a line that passes through 4, -1, and -2, 6, and we're going to write it in point slope and slope-intercept form, let's go ahead and find our slope. So if we want to find our slope, we need to do y2 minus y1 over x2 minus x1. So let's go ahead and label our points. I'm going to change my color. So let's say this is x1 and y1, and here's x2 and y2. Make sure you label those points correctly. The most common error I see students making is they say that this is x1 and this is x2. Remember, ordered pairs are x and y. So let's go ahead and plug in the numbers now. So the slope is equal to y2, which is 6, minus y1, so minus -1 over x2, which is -2, minus 4. So now let's simplify. So 6 minus -1 is the same thing as 6 plus 1, so that will be 7. And then -2 minus 4 is -6. So we've just found that our slope is -7 over 6. Okay, so let's go ahead and start off in point slope form, and I'm going to plug in numbers. So we've got y minus y1 is equal to m times the quantity x minus x1. So let's plug in what we know. We're going to leave the just plain y as y. Minus y1, it doesn't really matter what you choose. Let's go ahead and I'm going to choose the second point this time. So y minus, my given y value there is 6, is equal to m. Remember we found before that our slope is -7 over 6 times x minus x1. So minus, and then it's a -2. So for point slope form, all I would do at this point is go ahead and clean up this parentheses and make it x plus 2. Here is a legitimate form of a point slope linear equation. Let's go ahead now and we'll convert it to slope-intercept form. So let's go ahead and distribute -7, 6 to the parentheses, and then we can add 6 to both sides. So let's go ahead and we'll start the first part. So we are going to have y minus 6 is equal to, and then -7, 6 times x is -7, 6 x. And then I'm going to do this part on a little aside. So we've got -7 over 6 times 2, or in other words, times 2 over 1. So you can go ahead and say that that's negative 14 over 6 and then simplify from there. Or remember, you can always diagonally simplify when you're multiplying. Any numerator and any denominator can be reduced, basically. So since 6 and 2 are both divisible by 2, we can make that a 3 and this a 1. And now this ends up being a negative 7 times 1, so a negative 3, and then a 3 times 1, which is a 3. So we end up here with y minus 6 is equal to negative 7/6 x minus 7/3. Okay, so we still need to get it into slope-intercept form. We're closer, but we're not quite there yet. So we need to add 6 to both sides. So we've got y is equal to a negative 7 over 6x. And then here, remember, we need common denominators. So negative 7 over 3 plus 6. This is 6 over 1, so I need to multiply top and bottom by 3. So that ends up being plus an 18 over 3. And then negative 7 plus 18 is going to give us a plus 11 over 3. And now we have our equation in slope-intercept form. Okay, moving on. We're going to write the equation of the line shown on the graph in slope-intercept form. Remember, slope-intercept is y is equal to mx plus b, and this is fairly straightforward because remember, all we need to know are numbers to plug in for the slope and the y-intercept, and in this case, we can identify both fairly quickly. We can see the y-intercept right there. Notice the point where that line crosses the y-axis is positive 3. So we can go ahead and put a plus 3 in place of the b value. And then if we're going to find the slope, you can definitely name these 2 points. So this is the point 0, 3, and this is the point 5, 0, and plug into the slope formula. But I just think it's easier to count your vertical and horizontal changes. I always suggest that you start at the left point and count rise first. So here, in order to get from this point to this point, only moving horizontally and vertically, we're going to go down 3. Down 3 means it's a negative 3 for the rise, and then right 1, 2, 3, 4, 5. So if we go to the right on the run, that's positive. So we end up with y is equal to a negative 3 over 5x plus 3, and we're done. Okay, next one. We're going to write this equation in point-slope form. I want you to notice this is where point-slope form is really nice because the y-intercept is not a point we can easily identify. So I'm going to give you one, and then I want you to give me the other. So remember point-slope form is y minus y1 is equal to m times x minus x1. So we can find the slope. Remember, I suggest it's not a right or wrong thing, but I suggest in order to help you avoid careless errors to start on your left point and count rise first. So we're going to go up 1 and over to the right 1, 2, 3, 4, 5, 6. So our slope is 1 over 6. And then we can identify one of the 2 points. I'm going to go ahead and do this point right here, and that point is negative 4, negative 3. And I can plug that into point-slope form. So y minus negative 3 equals 1/6 times the quantity x minus negative 4. So let's go ahead and clean that up a little. So y plus 3 is equal to 1/6 times x plus 4. So that's one of the equations. I want you to tell me the other one. All right, moving on, almost finished. We're going to talk about parallel and perpendicular lines. The rule with parallel lines is that they always have to have the same slope, which remember is the m value, but a different y-intercept, which is the b value. For perpendicular lines, it's a little bit more complicated. We don't care about the y-intercepts. They can be the same or they can be different, but the slopes must be what's called an opposite reciprocal. And just in case you guys need a reminder of what perpendicular lines are, these are lines that not only intersect, but they intersect in a perfect 90-degree angle. Those are perpendicular lines. So let's go back to the opposite reciprocal. Opposite means opposite sign. So one of the slopes for perpendicular lines needs to be a positive and the other one a negative. Reciprocal means that you flip, you reverse the numerator and the denominator. So I always tell my students to think flip and change the sign. So some examples. If one line has a slope of, let's say, 2/3, a line perpendicular to it will have a slope that's flipped. So instead of 2 over 3, it's going to be 3 over 2. And instead of it being a positive, so even though it's not written, it's a positive 2/3, it's going to turn into a negative 3/2. Those two, if the lines you're looking at have those two slopes, you can say with certainty that they are perpendicular to each other. A couple of other examples, if you had something like a negative 1/4 for one of the slopes, then a line perpendicular to it is going to have a slope of positive 4/1, or you can just write it as 4. Or if the original line has a slope of, say, negative 3, remember that can be written as a fraction as 3/1. So we flip the slope, make it 1/3, and because it was originally negative, this one now becomes positive. One last side note, because vertical lines have what we call an undefined slope, and we'll talk about that more in just a minute. Kind of a side note is that horizontal lines are, and this is the sign for perpendicular, so are perpendicular to vertical lines. And that's always a side note I see, because vertical lines, you can't really say what their slope is, it's undefined. Okay, so now we're going to do equations of lines using these concepts. So right here on example 5, it says find the equation of the line perpendicular to y equals 2x plus 2 passing through 5, negative 3, and we're going to use point slope form. The only reason you have that original line is for that number right there, because the rule that we have to follow is that perpendicular lines have opposite reciprocal slopes. So our line, the line that we're going to find the equation for, has to have a slope of, we're going to flip the slope. Remember, originally it's 2 or 2/1. So we're going to flip the slope. So it's going to become 1/2 and change the sign. So instead of positive, it's going to be negative. Now we have an x1, y1. So we can go ahead and plug in. Y minus y1 is equal to m times x minus x1. And we can plug in for y1, it's a negative 3. For m, we plug in a negative 1/2. And then x minus x1, so minus 5. And I'll go ahead and clean up this first part and make it a y plus 3. But we are done at that point. Okay, next one. Now we're going to use the exact same original line, but we're going to find a line that's parallel to it rather than perpendicular. So again, the only reason we have that equation is for this number right here. So remember the rule for parallel. Parallel lines have the same slope. So our line, the line that we're going to write the equation for, is going to have the same slope as that line. So it's also going to have a slope of 2, and then it gives us our ordered pair that it's going to go through. Now I'm going to give you, because this question is asking for slope-intercept form, I'm going to give you a second way to find the equation of a line. You can plug directly into slope-intercept form. So what we have right here is we have our m value, and then what we can do is we can temporarily replace the x and the y in the equation with the point that we've been given. Notice I said temporarily, because at the end, remember the only variables that get replaced with numbers are the m and the b. So here's what we're going to do. In place of y, we're going to temporarily say negative 3, because that's the y value we've been given. In place of m, we'll go ahead and put 2. In place of x, again, temporarily, we're going to replace it with a 5. And then the reason we do this is because we've identified all of the values of the variable except for b. So this will allow us to solve for our b value. So let's go ahead and simplify. So negative 3 is equal to 2 times 5 is 10 plus b. And then all we need to do is isolate our b value. So we find that our b is negative 13. And at this point, we have everything we need to write the equation of the line and slope-intercept form. So we're going to put x and y back in as variables. We'll replace m with 2 and b with negative 13. And we have our equation. Okay, final concept, we're going to talk about horizontal and vertical lines. First, their slopes. I always look at horizontal lines as being flat and super boring. So there's nothing going on. It's like trying to drive from the panhandle of Texas to Kansas. There's nothing going on. It's just flat. There's no hills, no valleys. It's just flat and straight and boring. And so if I were on that road, I would tend to want to fall asleep. So I would say that the slope is 0. If that helps you remember, great. If it doesn't, you don't have to use it. But the slope of a horizontal line is 0. Another way to look at that is think about if you plugged in a 0 for the m value. Well, that would make this term completely cancel out. And the only thing remaining in the equation is the y-intercept. And that's the rule for horizontal lines. The equation for a horizontal line is always y is equal to, and then this number here is always going to be the y-intercept. And then vertical lines, The slope of vertical lines, I've already mentioned this before, but the slope is undefined. Let's talk about why that would be. You know how the slope of a line is the rise over the run? Well, I want you to look at, if we wanted to count rise and run, and we identified those 2 points. Well, we could say that the rise is 2 here, but the run is 0. And now what have we done? We've just divided by 0. So therefore, our slope is undefined. So hopefully that's convincing us to why the slope of a vertical line is undefined. So let's talk about the equation. Kind of like horizontal lines, what you end up with is the equation is just x is equal to, and then whatever number this is always the x-intercept. So let's do some examples there. So for these 2 lines, they're horizontal. So remember, the form is always going to be y is equal to, and then whatever the y-intercept is. Well, here's the y-intercept. So this equation is going to be y is equal to 4. For the yellow line, again, it's horizontal, so it's going to be y is equal to the y-intercept, and the y-intercept in this case is -3. And for these 2 vertical lines, our equation is going to be x is equal to, and then it's whatever the x-intercept is. So here's our x-intercept, so -5. And finally, that pink line, it's vertical, so our slope will be undefined. Our equation will be x is equal to the x-intercept, and the x-intercept there is +3. So make sure you're comfortable writing the equations of those horizontal and vertical lines. Okay, so example 11, and then you guys can do example 12. It's one that sometimes trips students up, so I'm going to challenge you with that one. But we're going to find the equation of a line perpendicular to y equals 7 and passing through 12, -8. Okay, so these can sometimes be confusing to students, but I want you guys to think about what this would look like. The equation y is equal to 7 might look something like this. So if this is 7 right there on the y-axis, this would be y is equal to 7. Now, what we want is we want a line that's perpendicular to that. Well, a line that's perpendicular to a horizontal line is going to have to be a vertical line. So we know that the line is going to be shaped like this. Now, if it goes through the point 12, -8, let's just say 12, -8 is right here. Well, I'm going to go ahead and move that line over so that it goes through that point. And now let's use the same kind of procedure that we used on the examples above. Remember, the rule for writing the equation of a vertical line is it's always x is equal to the x-intercept. Well, what would this x-intercept be? It's going to correspond with the x-coordinate of that point. So the equation is x equals 12. All right, you guys finish up that last one, and we will talk about it when I see you next.